Okay, now I'm recording. We missed the part about patterns, but that's okay. I'm going to miss one thing. That's a good one. So we did that silly stuff with patterns because our other topics are fake and real. No one's going to give you a calculator at the doctor's office and say, find some health rate formulas by hand with a calculator. It's all going to be in the computer. You type in people's numbers, their height, their weight, their age, and all the math happens automatically. But the job you have will require something that won't be any harder than those kinds of formulas. If you're working in the culinary field, then we're going to do all sorts of recipe scaling. And again, no one is going to hand you a calculator and say, plan the meal for 60 people using only the calculator. No, if you're actually working as a chef, then they have software that's going to do that, and it will tell you how much to shop for and maybe even have the prices as part of it and so on. So all of that kind of thing will be done with a computer program instead of by hand. But you will also have to do other math when you're a chef that, or running your food cart or whatever, that you do by hand, and it won't be any harder than the recipe scaling. So the things we are doing in Math 25 are, one, to show you how all the software you will use in real life in your job actually works. You can use the software a little better or know if something is funky if you know the math that's behind it. And also it's a stand-in. The people who are going to hire you can say, okay, if you can do this math, then you can do the math that actually is your job to do with a calculator. And the workplace changes enough that LCC can't predict what that is. What is it that someone running a food cart will actually be doing with a calculator 5 years from now? Who knows? But whatever it is, you will be ready for it. And by passing Math 25, everyone will know that. So we're looking at patterns the last few minutes then, just to say that formulas come from patterns. Some of the formulas we use, we will study the pattern and find the formula ourselves. Others are too complicated, and we're not going to actually take the time to look at all the patterns behind these formulas. I'm just going to give you the formula and you're going to plug things in and use it. But in all of them, they come from formulas, or they come from patterns. It's not like somebody did some magic to make the formula happen. So, okay, back to here. So there's more of them. I'm not going to do them now. They might be a good warm up when I see you on Thursday. And I want to conclude with one. If we were in a classroom, I'd break you up into groups, but here we'll just talk about it all together because breakout rooms in Zoom are a pain. So here I have a very interesting table for patterns. So we're modeling a raindrop. And this isn't very accurate because this is just a two-dimensional thing with squares, and that's not what microscopic water droplets really are like, but this is good enough to make our point in the math class. So in the first row, we have one little bit of water droplet, and you can barely see underneath it that the bottom two edges have a kind of blue highlight to them. If you can't see that, then I will just make it a little bigger. So it weighs 1. There's one orange water droplet. And the air resistance on the bottom is 2, because there's 2 edges at the bottom. So this is like one of those water strider bugs balancing on a puddle or a pond or something. So right now, the bottom number is double the weight number. If a few more water droplets group up together, then now we have 1, 2, 3, 4 as the size of the next square, and we have 1, 2, 3, 4 along the bottom. So the weight has caught up to the air resistance. If we keep getting bigger, the next square will have 9, and then the bottom now has 6. So now the weight is bigger than the resistance, slightly. Or water strider that is balancing on, in this case, air, because air, if you've stuck your head out of the car window, you know air pushes on you. Then now the weight is getting bigger than the amount that the air is pushing as this tries to fall with gravity. So if we continue the pattern, what will happen? Why is it that clouds, this one here, clouds, oops, why is it big and small? Clouds are very small dispersed water droplets. Clouds are floating, but rain is falling. If the water droplets clump together and get big enough, then it falls. So, okay. So somebody share, what are we learning from this?
Math, please.
Talk about the patterns. We have a pattern of how the weight is getting bigger and a pattern of how the air resistance is getting bigger.
The more it weighs, the lower the resistance.
The resistance is growing. It's just not growing as fast. Can you figure out either of these formulas?
$18 for the weight.
For the weight. The next weight will be 16 if it's a 4x4.
Okay.
So what do we call the pattern of 1 turns to 1, 2 turns to 4, 3 turns to 9, 4 turns to 16?
The number times itself.
Yeah. If you're fancy schmancy, then you would write that as n squared, but we don't have to be fancy. So you can see why squared is called squared, because it's making squares, right? 3 times 3 is 9, 2 times 2 is 4. The air resistance, though, 1 to 2, 2 to 4, 3 to 6, what's happening there?
The number's doubling.
It's only doubling. Can you see why? Because every step we're just adding 2 more to whatever was there before. So it's just a +2 each time. And we've seen that if you go down with +2, that must mean you're multiplying by ×2. So this one is a linear kind of growth. It's just +2 each time. This one is a squared kind of growth. And if you've been following the news of the pandemic, everyone is worried. We want it to grow in a linear way that the hospitals can take care of people, not an exponential way that will flood our hospitals too much. So we don't know how much bigger does the weight need to be than the air resistance for our water droplet to finally fall. But whatever that is, whether it's 100 times as much or 1,000 times as much, then it will eventually happen, because the weight is getting bigger at such an increased rate compared to the air resistance that however much bigger the weight needs to be compared to the air resistance, it will happen. We will have rain that falls. Okay, questions about that? Okay, then let's keep going. This triangle formula is something I'm going to skip over for now. It's kind of fun. There's all sorts of things in nature that involve this triangle formula. Now, if we were in a normal class, at this point, I would pass out to you a copy of a hardcover book called Factfulness. And at the end of the week, I'm going to see how I can actually get a copy to your hands, because I have a whole bunch of them in my office at LCC. But I am sure that the math office is too busy dealing with crazy things to say, hey, I want to, whatever, sit out by my car in the parking lot and have my Math 25 students swing by sometime and pick up books. So we'll talk about this later, but this is a great book, and it talks about how to understand the world with math and mistakes that people make when trying to understand the world with math, and why the news media always seems more depressing than it should be, and things like that. So I'm going to skip it for now because I can't actually give you the book, but fairly often there'll be these sort of interludes where we talk about good lessons from this book. And I'll highlight a study skill when we get to them in the notes. So time management, if you click here, then there's a time management thing. So I'll look at that later. Okay, now we can kind of really start. So patterns make formulas, and the first formulas we're going to study are about calories. Let me check in once more before I start a new topic. Anything else about what we've done before I start a new topic? No? Okay, I'm going to actually take a quick break and do homework. So we've done a topic. What do we do with that? So back to this main page, and I'll click on the dog to go to homework. The homework page I've updated some. And we have different types of homework. So the first thing is the example problems. Go back to the topics and go over the example problems we did in class. See if you can do them yourself without looking at the answers. The ones we skipped over on purpose because there's more than we have time for in class. See if those make sense. And I'll just give you a heads up that patterns is the least important topic we do. The first day of any class at college, you do sort of something that's interesting but not important, because lots of people don't join the first day. And if they miss it, then you want them to miss something that's not terribly important.
Can you
so
share
don't worry too much. Can I share my screen? Sure. I'm sorry I wasn't. Thank you for telling me. Okay, let me back up. So I went to the homework, to the dog thing here, and it says that the first thing to do is some example problems. So I would go back to the math topics and say, okay, which ones that we did make sense to you? And can I do them without looking at the answer at first? And here's one that we didn't do during class. Can I do this one? And then my heads up is if you can't do the patterns one, don't worry. They're just sort of there to be interesting. They're not something we need for the rest of the math class. But that's only patterns. And calories, try and make sure you can do all of calories when we actually get done with it. Then the next part of homework is textbook problems. And in Math 25, you'll skip a lot of this. But if we find out that you need some review with whatever, then go in the textbook and do the review of that. And as we start using Math 20 material, I will show you where it is in the lecture notes, and I will show you where it is in these two textbooks so that you can do some review homework if you need it. So for now, none of that. Then a problem bank. This isn't for you, this is just for 20. I want to make problems for the problem bank. What's supposed to happen is that you can say, oh, look, here's a problem that I could go and see a video of how someone does it. Or I could just look at the steps, or I could just look at the answer. But for the Math 25, since, again, people aren't teaching this in high schools and colleges like they should, we don't have a problem bank. No one has made a lot of videos online. So if there's something you want me to record a careful short video of outside of class, let me know, and I will put it in our problem bank. But right now, if I try and go to health decisions, it's going to say, there's an error. Your silly teacher hasn't put anything in here yet. So it was just a brand new idea that I had for this term that we don't have material yet for 25. So after you review your example problems, you're probably going to jump all the way down to the random problems. So the random problems have another accordion, and when you unfold it, whoops, you're not in shape-shifting, then here is some pattern problems. And they all have an answer, and you can reload the page. Whoops, reload the page. And it will have a different one. Calories is a little more interesting, and so on. So this is where you can do a bunch of homework practice. You can have as many problems as you want randomly generated for your topic. When you've done some random problems, when you're happy with the example problems from class, then you finally start the homework to turn in. So we click here. Again, there's an accordion, unfold it. And for each topic, there's 10 problems. So work on those. And it says here, important, after you're very happy with your answers, turn them in. So I click here and there's the same 10 problems, but now with multiple choice answers. So I will click on those. I'm just going to pick the first one to get this done. Oops, there's a typo there. I need to fix that. Okay. And then when I say process my answers, it gives me a code. So I take this code, copy and paste it into an email. You send it to me and I tell you how you did. I could have the website automatically grade you, but that's no fun. It's nicer to get emails from each other and for me to actually kind of be in touch and see how you're doing and so on. So that's how your homework will work. Should I go over it again?
Yes.
Yes, okay. So for homework, click on the dog and it'll say types of homework. Do example problems from the lecture, the ones we did and the ones we skipped over. If you have some Math 20 textbook review to do that. Probably not yet. Skip the problem bank. This is just for right now my homework. You're going to say, I want a problem bank problem of this topic. Do some random problems for whatever we did, and then do the 10 problems to turn in. The reason we do that is this levels of understanding, that it's perfectly normal for any math topic that at the first level of understanding, what I do on the board makes sense to you. Lecture is helpful. A totally different thing is if you can do open book work. We've all had times where the math class seemed happy and fun, but you get home, you open your textbook, and it's like your brain has turned off. What's happening? Because that's a different level of understanding. The third level is where you can do closed book work. You don't have your notes, there's a time limit, and we don't actually do that in Math 25. Everything, every test is going to have no time limit. You can use your notes, you can use your calculator. So we're only trying to get you to the second level because that's realistic. At the job, no one is going to hand you a calculator and say, save the company, make a business plan, go into this room for an hour, don't talk to anyone, don't look at books, tell us what you need to do. Right? Real life is always open book with notes. So at the bottom, it talks about prompt and enough homework problems, and this is about time management. So sometime today after our class, do a few problems just to see if this is going to take a lot of time this week or not. And, you know, is this going to be a fun weekend where you have no math homework, or is this going to be a time where you need to set aside a few hours to get your math homework done? And I would be worried if I was a student and I couldn't do this before dinner or bedtime of that same day. But depending on jobs and kids and things, I might not have time on Tuesday to actually sit down and do a bunch of math homework. So later on, you'll do enough math homework to get the practice you need. Unfortunately, math isn't like the Matrix movie. I would love to just be able to plug something into you and ta-da, you know all the calories topic perfectly, but that's not how life works. It's more like martial arts or pottery or something where you just have to do it a bunch. And so sometime you will do enough homework problems to learn it. But I don't expect that to happen today on Tuesday, because that's not how real life is for most people. Okay, is that enough talking about homework?
Yes.
Yes. Any questions? We're all good? Okay, then let's actually get to calories. So patterns was interesting. Now you know why clouds float and rain falls, but let's actually do something that your employer someday might care about. So calories are a measure of energy, and our body uses energy, burns lots of calories just for breathing, circulating blood, maintaining her body temperature, growing and repairing cells, all of that metabolic stuff. When we exercise, then we burn more calories. So we have the exercise formula is calories burned is weight times the minutes times the scale factor. What does that mean? Well, first, if I weigh more, I burn more calories. If my 8-year-old kid, real life, so my kid's went running with me this morning, and since he's only 8, we couldn't go very far, about a mile. So he didn't burn as many calories as I do because he doesn't weigh very much. So moving his body around just doesn't take as much energy. The minutes is how many minutes you're doing your exercise. So the longer you go, the more energy you burn. That's not surprising. And the scale factor is a bunch of baloney. We have this chart here that we're going to pretend is reliable, but it's not. Right? When I go running, how I move might be different than when you go running or when my kids go running or something like that. And where we go matters. If I'm running up Dillard, that's a lot different than if I'm running on a flat track. So all of these numbers are sort of just garbage. If we were really doing personal training and exercise coaching and stuff, there are better lists of numbers out there. And there are ways to actually attach things to people and measure and see what their calories per pound per minute number should be for that kind of exercise. But we don't care. This is a math class. This isn't, a personal trainer on the job. So we're just going to pretend these are the numbers we're using so we have something to plug in the formula. Okay, so it's amazing that the formula is actually this simple because it could depend on age, it could depend on weight, it does. It could depend on height or sex or other things, and it doesn't. So at this level of accuracy, whether you're old or young, whether you're male or female, doesn't matter. The formula still gives you a good estimate of how many calories you're burning. So let's do an example. Arthur weighs 150 pounds. He runs for an hour and then does half an hour of weightlifting. How many calories does he burn? I'm going to first grab the formula. And I am going to then grab the problem. And I should probably also at least once grab a little box there. Okay, now I just plug things in the formula. So I have two parts to this. I have runs for an hour and I have half an hour of weightlifting. So for my first one, runs for an hour is going to be 60 minutes. His weight is 150 pounds. And the scale factor, I have to look on my table. So we're pretending that he runs at 0.09. I'm going to take a quick tangential comment about writing decimals. So I just wrote 0.09. If you wanted to just write 0.09, that is great. I am writing the 0 because I'm lecturing. So if I say 0.09 or write it, it just gives your brain, your eye, your ear, an extra little alert that decimal is coming up. But if we were just doing a study session, working together on homework one-on-one, I probably would not say the 0.09. I would just say 0.09 or 0.09. So you don't have to write that in front if you don't want. Okay, I plugged in my things. So far, so good. Now it's the calculator's work. So 150 times 60 times 0.09 gives me 810. Then I have to do it again. His weight is the same. What do I do for minutes now?
30.
30, half an hour. And scale factor for weightlifting. Again, there's lots of kinds of weightlifting, but we're pretending it's all the same. And that's my number. So calculator's turn, 150 times 30 times 0.039. So it's telling me on my calculator 175.5. I'm going to round it to 176. Saying we know anything to a fraction of a calorie is ridiculous because, again, these numbers are all sort of garbage anyway. And is he exercising exactly half an hour? Is he doing exactly the same kind of weightlifting the whole time? No. So in truth, if we knew this even to the nearest 10 calories, we'd be probably doing very well. I'm certainly not going to keep any decimals in my answer. Then finally, I'd add up the 810 and the 176. Oops, 170. And get 986. That's worth putting a box around. Okay, everyone happy with that example?
Yeah.
Yes.
Yes, okay. So, ta-da, our first real Math 25 problem. Okay, Odette weighs 110 pounds. She bicycles to the gym in 10 minutes, plays basketball for 2 hours, and then bicycles home in 20 minutes. How many calories does she burn? So I probably should do the same thing. We have the formula. We have the table that's inaccurate, but we're using it anyway because we need something. And we have this problem. Okay, your turn. I'll do this, but first you get a head start. Make sure you understand things. reason it's hard for me to unmute myself when I'm sharing screen.
Is it 881 one?
Take 81. You were cutting out, Donna. Tell me again.
Is it 881.1?
For the answer, I don't know. Let's check. It's 981 total. So she bicycles for 10 minutes. Let me write that a little better. And then she bicycles again for 20 minutes. So we have 30 minutes of bicycling.
Okay, I see my mistake.
And then she has basketball for 2 hours. So 120 minutes basketball. See if I can fit it on my whiteboard. So for the biking, then it's going to be her weight, 110 times the minutes, 30. And the bike number we're given is 0.45. Everyone knows the squiggly equals. That means I just rounded in this step.
Just saw that.
Okay, so 110 times 120. Okay, everyone get that?
Yeah.
Yeah.
Could you have done 2 bicycle steps separately, one for 10 and one for 20, and then added them up? Sure, that would also work. That's just too much for me to fit on my screen.
David, do you always round up or, round it?
Do I always round it? It depends on the problem. If we were doing carpentry, then yeah, I could measure something to the half an inch easily, right? If we're doing exercising, no, trying to measure someone's burning calories to the half a calorie isn't going to happen. So it depends on the context. The general rule is that whenever you're doing math, look at the numbers they gave you. And if your answer could be that accurate or more, then either keep the same number of decimal places or add one more. So since most of our stuff have no decimal places, then probably my answer shouldn't either. We just don't know if her weight is really 110 or if it's 109.6 or if it's 110.4. Right? Since that didn't say 110.0, we don't know how really precise her weight is. So my answer should probably have a similar amount of precision.
Okay.
Okay, I'm skipping 13. So this means that after class, the first part of homework was to go back through example problems, try this one, peek at the answer when you're done, things like that. Okay, fat versus carbohydrates burned. If you're trying to lose weight, you want to burn fat calories, not carbohydrate calories. The practical lesson is never mind, exercise a lot. But there's actually some interesting math. So when you do more intense exercise, your metabolism burns a smaller percentage of fat calories. The carbs you can get quick energy out of for your intense exercise. But intense exercise burns many more calories total. So even though you are burning more carbs as a percentage, you will burn more carbs and fat total. So number 14 asks you to check that. This will be a great one to start class with on Thursday. So when walking, 3/4 of the calories are fat and 1/4 are carb. When running, it's half and half. So two people, they both have the same weight. They both exercise for 30 minutes. Find how many calories they burn, just like we did, right? Just that kind of thing. And then for the walker, break it up 3/4, 1/4. For the runner, break it up half and half and see how it works that way. So I'm going to skip that for now. That's a great one to sort of check in with this as a review on Thursday. Testing the formula. Is there some way we can check the exercise formula? We can't directly. There's like no readout on our forehead that says how many calories we're burning, but we can estimate it. When we exercise, our muscles need more oxygen. And aerobic exercise, what counts as aerobic, is when the more energy you use, the more oxygen you need. So our breathing and heart rate increases to get us that extra oxygen. So we could make a pattern ourselves. If you're resting, if you run a minute, if you run 2 minutes, if you run 3 minutes, then what's your breathing rate? How many breaths you take in 20 seconds? What's your heart rate? How many times your heart beats in 20 seconds? And you could look for a pattern. When some Math 25 students did this in spring 2019, their heart rate had no good pattern, but their breathing rate made a surprisingly nice pattern. Another group did the same amount of time, but they were just faster and faster. So they started at rest, then they walked down a hallway, then they jogged and did the same distance but twice as fast, and then they ran and did the same distance but twice as fast. And they again, in 20 seconds, how many breaths did they take at the end? What was the heart rate of their volunteer at the end? And they got some nice patterns out of it. And this one did how many jumping jacks could you do in 30 seconds? And again, no pattern sometimes, but sometimes there was a pattern. So if we were actually together in a classroom, I would have you form groups, pick some sort of exercise that you could do either a longer or the same amount of seconds but faster, and see for your brave volunteer whether you had a pattern with your breathing rate or your heart rate. But since we're in a distance learning class, this is just going to become kind of optional homework. If you want to play around with this at home, you can. And it's interesting, but not something you have to do. Okay, I'm going to stop the share for a moment. Questions about calories and exercise. We're now done with that subtopic. No, Tony's shaking his head. Everyone's okay?
Yep.
Yeah. Okay, calories and food. So calories are not all created equal. 1 gram of fat has 9 calories, which is more than twice as much as the 4 that protein and carbohydrates do. So these are like conversion rates. They can switch between grams and calories. So if Arthur is in a rush, he eats a plain 4-inch bagel in the car. Here's our thing for the bagel. Let me grab that first.
Can you share?
Yes, I will go back to share my screen. Thank you. Okay. I'll start over since I forgot to share. So here we go. Fats have 9. That's more than twice as much as the proteins and the carbs at 4. So we're going to switch between grams and calories. Here's our nutrition facts for the bagel. And our first problem is about Arthur. So you've seen these kinds of labels on food before. How many of the bagel's calories are from carbohydrates? It doesn't tell us directly. Up top, it says that from fat, there were 13 calories. But the packages don't normally say from carbs. So we have to do a little math. The total carbs is 47. And we just saw that each, 47 grams, and each gram for a carb would have 4 calories. So we're going to do times 4. $188. From protein, it's pretty much the same. There were 9 grams of protein. Each has 4 calories. So we'll get 36 calories. From sugar, sugar is a kind of carb. So the sugar is already included in the 188. But if I wanted to just look at it specifically, because sugar is a kind of carbohydrate, then it's another times 4, because carbohydrates are times 4. So we had 188 calories from carbs. Oops, that didn't change. There we go. Of those, 20 were sugar. So there must be 168 of some other kind of carb. Questions about that problem?
No.
No, holler if you do. Okay, let's do the next one. Actually, that one we can just talk about. So the package says it has 1 gram of fat. 1 times 9 is 9. So that should be 9 calories from fat. But the package also says it has 13. So why is there a difference? Why don't the 9 and the 13 match up?
Because one's the entire package and the other one's just a serving.
No, they're both servings. All of this is just for 1 serving. That's a good try, though. If I do 13 divided by 9, I get 1.4. So that's my clue. Okay, I'll spoil it for you. The bagel probably does have 13.
So-
This number is probably right, but what's probably happening is the 1 is really a 1.4, that they rounded it to look better on the package and only put the 1. Someone else was talking. Did I spoil your thunder? I'm sorry.
No, I was just noticing the difference between the calories from the 9 calories and the 13 calories.
Mm-hmm. Okay, let's do this one. Okay, a 1 cup serving of 2% low-fat milk has 5 grams of fat, 12 grams of carbs, all from sugar, and 9 grams of protein. So I want to change these grams into calories. Show me you've been following along. What do I do?
Multiply the fats by 9 and the carbs and proteins by 4.
Great. So 9 times 5 is 45. 12 times 4 is 48. 9 times 4 is 36. So I've used these numbers to go from grams to calories. If I wanted to do sugar, I could say, oh, by the way, the 12, the 48, that's sugar also, since it said it was all sugar for the carbs. If I wanted to be very nice, I could put labels better from fat, from carbs, from protein. Okay, pardon my handwriting. Everyone happy with that?
Yeah.
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 Oh, okay. Should we do another one, or have we had enough of this?
We
think
could
we
do
have-
another.
Do another. Okay, so this time we have 1.3 grams of fat, 22 grams of carbs. And I'm going to switch to a different color to show that extra well that this sugar is part of the carbs. And 2.5 grams of protein. Okay, same as before. What do I do?
You times them by either 4 or by the
Times
9.
by 4 or 9.
For the,
You had it, but you cut out. Yeah, 9 for the fats, 4 is for the others. So calculator time, 1.3 times 9. So now how should I round this? Should I write 11.7 calories? Do we ever talk about calories with tenths of a calorie?
not yet.
No, everyone tends to talk about food with whole numbers of calories, right? So I should probably just say that I'm rounding, round to the whole number. (22 times 4), that I can do in my head. Of those 88, 9 times 4 is 36 from sugar. The others must be some other kind of carbs. And then 2.5 times 4. So 2 4s is 8, and then half of 4 would bring us up to 10. Okay, everyone happy with that slide?
Yeah.
Yes.
Yes.
Okay. So we're running low on time. I'm not going to rush ahead. We've all heard about the calories per day recommendation. So there's a little bit more there. We can do that next time. We're going to start talking about percentages. There's the RIPLOP acronym, right into percent, left out of percent, which you might know from Math 20. If you don't, I will show you that in just a moment. And then we had another interlude if you had your book, which you don't, and an encouragement to do some study group work, and then we'd start our next subtopic. Okay, let's look at homework real quick. So you're done with class, click on the dog. Look at the example problems after class, the ones we did, the ones we skipped over. You can skip the textbook and problem bank thing. For random problems and health decisions, you can now go to patterns and/or calories and try some random problems. This should look quite familiar. Check your work when you're done. Reload the page to get more of them. That will be different. And when you think you're all done, then you can go to the turn-in problems and turn in the problems for patterns or for calories. And you're not ready for this yet. This is more of the USDA stuff we don't have time to do today. We'll do it on Thursday. So if you want to start the turn-in homework for calories, you could, or you could just wait, either way. But we have done all the stuff for patterns, so you can start working on this one. If you happen to finish, then you can do the multiple choice and give me the code at the bottom. I'm not assuming that before Thursday, everyone will have time to finish a homework set. For some of you, because of jobs and kids, the weekend is when you'll get your homework done, and I understand that. But if you can fit it in your schedule, the sooner is better because it's fresher in your mind. If you haven't sent me a code name, please do. When we go to the achievement list, then I have only a few students that have sent me a code name, and then I can say which stars that they are getting checked off with. So here is a sample person that has a bunch of stars checked off, and you will be happy with check marks someday too. I encourage you to work in groups, and that means I need to check in about when the other students wanted study groups. So can everyone see the text chat? So Monday, noon to 1 p.m. was when
Screen's
the math.
not showing.
What? Yeah, I'm not sharing my screen. I'm just
Your screen's
taking
not.
it. Yeah, that's fine. It's a mess anyway. This is just my notes from when they wanted to do something. Tuesday, 2 to 3. And Friday, 3:30 to 4:30. So if you look in the text chat, Monday, noon to 1, Tuesday, 2 to 3, and Friday, 3:30 to 4:30. So that's what so far people have wanted. And we can certainly do more than that. If there's another hour that you want me to schedule in the week, then go ahead and let me know, either now or in email or whatever. If those are enough hours, then great, whatever. But that's when I will be around outside of class, just for you to show up and do homework with me around in case that helps. And if you can, I would always do homework with other people. I know that's not practical. We're not at U of O, the ivory tower, where no one has jobs or kids. But homework is best in groups. You learn more talking about it. So as much as you can do homework with other people, do that, whether it's someone in your house or other Math 25 students at a study group. Any other questions before we're done? There's one more thing I want to show you on the screen. So the lecture note page will have all of our stuff that we do. So there's nothing yet because we're just having our first class, but you could see in the Math 20, they now have links to the whiteboard. They have a link to the Zoom recording, and they have a link to the YouTube version of the recording. So that will be up very soon. Sometimes it takes only a few minutes, sometimes it takes hours for Zoom to process the recording. But certainly before dinner, you will have things here in the lecture notes page that looks like a white square with my handwriting. And I will send out an email to everyone after class with a review on what we did and what your homework is and things like that. So, okay, anyone want other office hour study session time? Any other questions before we're done?
Where do you set up the code name thing you were just showing?
Where do I set them up? You just pick it. You just send me an email and say, my code name is whatever, Albus Dumbledore. What I do, if you're curious, I can show you. So I do all the website programming just in a plain text editor. Can you see my text editor now?
Yes, I can.
So if I go to the JavaScript gradebook, then this is what somebody looks like. They have a code name, and then for all the different stars, it starts out false. And as you do things, I just change it from false to true, and you get a star on your thing. So this is easy for me. I can look at all on one screen. It's not like a spreadsheet where I have to scroll sideways to fill in assignments and things like this. So that's the background for it if you're curious. But you just send me a code name, right? Send me an email, give me a text, put it in the private chat in the Zoom meeting here or whatever. But actually don't do that because I'm not sure when chat is saved if the private things become public or not. I would hope not, but.
Send you an email.
Yep, send me an email, pick a funny code name. I'm going to stop the recording if we're just sort of doing this end of